All right, folks, in this video, I'm going to attempt to summarize the entire history of Earth. This outlines exactly what you're expected to know, so if you'd like to pause and review it, please do. There are a lot of terms in this presentation, but I think I can make them easy for you as we go. But if you'd like to pause and define and review, please do. So the main idea of geologic time is that scientists take all the fossil evidence and all the rock layer evidence from around the world and kind of put it together to kind of paint like a simplified version of what um, Earth was like, throughout its history. So it begins with, the formation of the Earth, and it goes on until present time, and it divides Earth into units of time called eons, eras, periods, and epochs. It outlines the diversity of life forms that were present in Earth's history according to the fossil record and some major geologic events such as mass extinctions and things like that. So, what's great about this picture is it shows some major time periods of Earth's history, such as the Paleozoic Era, the Mesozoic Era, and the Cenozoic Era. It shows you some common index fossils or organisms that existed during these eras, such as the Paleozoic era has a lot of marine-like organisms in the lower layers, and then we see more dinosaurs in the Mesozoic era, the middle layers, and then more mammal-like organisms in the more recent layers, and then here we are today. So not only does this show, the fossil evidence, but the rock layer evidence, and it also incorporates the law of superposition. So this is the general pattern of what we see in the fossil record according to the fossils that we find and the rock layers around the world. So the major units of geologic time include eons, which are the largest, eras, periods, and epochs, which are the smallest. So you'll see a lot of diagrams like this where they show, geologic time being divided into different units of time. So there are, basically two major eons in Earth's history. The Phanerozoic era includes three major eras: the Cenozoic era, the Mesozoic era, and the Paleozoic era, which we'll go over quite extensively. And then eras are further divided into periods, which are divided according to, biodiversity or geologic events. And then periods are also divided into, epochs. And you can see that, in more recent history during the Cenozoic era, there are a lot more epochs and geologic time because there's more fossil evidence. We're able to divide a little bit more, precisely. But eons are the largest. Then those are divided into eras. Eras are further divided into periods. Periods are further divided into epochs. So just to kind of put the geologic time scale into perspective, let's just say all of Earth's history is on a football field. So here we have the Earth forming here at one end zone, and then we have today over here at the other end zone. What's amazing is that, nearly 90 yards of this is considered the Precambrian time, where there's very few organisms in the fossil record. A lot of this time, is the formation of Earth, impact events, no atmosphere, no oceans, no, a lot of volcanic activity, impact events that the Earth was significantly different in the past, according to the rock layers and the fossil evidence. But what we're going to do a lot in this unit is, we're going to focus a lot on the extraordinary biodiversity that does occur, in more recent geologic time. So if we zoom in the last 10 yards, what we have here is, human beings in the fossil record are really nearly right on the end zone, which is fascinating. We just don't see, fossil remains of anything resembling human beings whatsoever, in the distant past, not even close to back here. And then what we see is dinosaurs, which went extinct over 65 million years ago, is in the last 2 yards of Earth's history. And the first dinosaur fossils that we see, is within 5 yards of an entire football field. So you could see a lot of the biodiversity on Earth, occurs relatively in more recent geologic time. So as I was saying, Precambrian time, the Earth's formation is, over 80% of Earth's history. More than 4 billion years of time is during the Precambrian age. And it's characterized by, a lot of impact events, volcanic eruptions, the formation of the moon. A lot of interesting geology is occurring during the Precambrian time. However, the geologic time scale is generally emphasizing, biodiversity and the living things that existed on Earth, and you know, and what happened to them. So this picture here, I think, depicts Precambrian pretty well. Here's the formation of our moon and what the Earth might have been like in the past. Probably even worse than this. And it starts with the beginning of Earth's history, which is approximately 4.6 billion years old, and that's according to rock evidence from the moon and the Earth and even our solar system. So what we see is there really wasn't any life on Earth at this time as it was continuing to form. It really wasn't even conducive for life forms to even thrive. But after about a billion years, so about 3.5 billion years ago, or a billion years into Earth's life, we see the beginning of really simple single-celled organisms. Here are some of the oldest fossils we've ever found of some single-celled organisms that did not live with any oxygen. And this picture here shows stromatolites, which are kind of like colonies of bacteria, which actually wasted oxygen and are theorized to maybe even have created our atmosphere. So not many fossils have been found during the Precambrian time, simply because maybe those organisms weren't around then, or they're geologic uh, events that wouldn't allow these organisms to fossilize. But according to the fossil record and what we've found, we don't find many fossils that existed in these rock layers. So what happens is, at the end of the Precambrian time actually marks a new eon, which is the eon of life, the Phanerozoic eon, and that begins with the first period of Earth's history that begins the Paleozoic Era. And it's called the Cambrian Explosion. It's actually not a bad event. This is actually an explosion of life. So the Precambrian time ends with an explosion of a great diversity of living things, which begins the Paleozoic Era and the first period of life, in a sense. So the Cambrian explosion is a remarkable event where all of a sudden in the fossil record we just see an abundance of new organisms in rock layers that is fascinating. So that begins the Paleozoic Era, which is, a lot of the organisms in these rock layers are well adapted to marine life, or life in the water. So the Paleozoic Era is generally characterized by the age of marine water-like creatures such as trilobites. Here we see some pictures of what organisms, may have looked like according to the fossils that we find. And this is where we see the first land plants, simple mosses, ferns, cone-bearing plants, seed plants. And what's amazing about the Paleozoic Era is it began about 542 million years ago. And remember, the Earth's about 4.6 billion years old. It lasted till about 251 million years ago. So the Paleozoic Era was almost 300 million years long. So these organisms were well adapted to Earth at that time, thrived for nearly 300 million years. And a lot of the organisms that we first see in the fossil record include the first invertebrates, or organisms that had no spines, such as trilobites, were the poster child of the Paleozoic Era. Here's a fossil of a trilobite. We find them all over the place in just the rock layers that were part of the Paleozoic Era. Brachiopods are these shell-like organisms. We see the first fossilized vertebrate fish, the first insects, the first amphibians, and reptiles even become dominant towards the end of the Paleozoic Era. So this right here is almost 300 million years of time here. What we see is the continents during this time were a lot different. Obviously due to plate tectonics, the continents were just located in different areas. This would certainly alter the climate. There were more warm, shallow seas at the time. Here are some, pictures of real fossils that are actually, characteristic of the Paleozoic Era, such as trilobites, brachiopods, the first vertebrate fish, and reptiles. Here you see, the major periods of the Paleozoic Era, beginning with the Cambrian Explosion and then ultimately ending with the Permian mass extinction, which would start the beginning of a new era. So how did the Paleozoic Era end? It was the greatest extinction that has ever occurred. I mean, significantly larger than the extinction of the dinosaurs. More than 90% of all living things died off, and it's actually not really well known why. There's maybe a combination of things that occurred, but some common theories include extensive volcanic activity that had dramatic impacts on the climate and the air and the water that caused many of these organisms to go extinct. But there are other theories such as impact events and just the continents moving and causing the oceans to get deeper. But it was probably a combination of all of these things. But the greatest extinction ever ended the Paleozoic era. But what we're going to find out is when we have a mass extinction, the organisms that are left over thrive and begin a new era. So the organisms that did survive the Permian mass extinction ultimately became the dominant organisms of the Mesozoic era, the middle era, which is basically the dinosaurs. The word dinosaur actually means terrible lizard because that's pretty much what they were. The Mesozoic era, lasted almost 200 million years, and which is a phenomenal amount of time. Here are the three major periods of the Mesozoic era. We could see the first dinosaurs arriving in the fossil record, Pangaeas starting to split up, the first early mammals are in the fossil record, the first birds, the first placental mammals, and look, these are millions of years of time in between. You have the first flowering plants, and then about 65 million years ago, the mass extinction of the dinosaurs occurred. So here you see the continents were significantly closer. Pangaea was starting to break up, and here are some common organisms that characterize the Mesozoic era, such as ammonites. And you can see here the Mesozoic era is just about a million years shorter than the Paleozoic era here, about almost 200 million years, which is about three major periods. And then 65 million years ago, another mass extinction ends one era and then ultimately begins a new era. So, a little overview of the Mesozoic era. Again, biodiversity continues to increase over Earth's history. We have, diverse reptiles, including dinosaurs, the beginning of birds and mammals in the fossil record. We have grasses arriving in the fossil record. Flowering plants become dominant. And the climate, had a strong influence on the Mesozoic era as the continents were shifting and causing the oceans to get deeper. And mountains were beginning to form due to plate tectonics, all altering climate significantly, and ultimately the organisms that thrive in those environments. So, really, what did happen to the dinosaurs? Well, an asteroid impact is a very common theory. There's a lot of evidence that supports the asteroid or meteor or common impact event. And what we do know is that, more than 70% of all living things died suddenly in the fossil record at the end of the Mesozoic era. But what's interesting about the asteroid impact event is not many people know that it's actually the fallout after the impact event that may have caused many of the dinosaurs to go extinct. For example, when all that debris is blasted up in the sky, it blocks out the sun, and then the plants die, and then the dinosaurs that eat the plants die, and then the dinosaurs, the carnivores that eat those dinosaurs die. The climate got significantly cooler, and large reptiles are not well adapted to cooler climates. And then, disease and a lot of other things. So, really, the asteroid impact caused a whole chain of reactions, climate changes, volcanic eruptions, um, you know, ecosystems and food webs, break down and cause a mass extinction. So, I like this picture because it kind of depicts what the fallout may have been like after that asteroid impact. So after that mass extinction, the mammals were able to take over the environments that were once dominated by dinosaurs. Mammals were more adapted to the cooler climates, warm-blooded, fur, and what we see is the biodiversity, increased in the Cenozoic era. That's true for Earth's history in general. Cenozoic era is characterized by many ice ages and mammals. There was global glaciation, including all of North America and Europe. And the climate on Earth was significantly cooler than during the Mesozoic era and the Paleozoic era. We see new mammals appear. We see the diversity of life increase. We see flowering plants become extremely popular in the fossil record. And humans are also part of the most recent period of the Cenozoic era, according to the fossil record. So you see here the continents are more in their current locations that we're familiar with today. Some common fossils that we see during the Cenozoic era, such as woolly mammoths, and you can see it's only been about 65 million years so far, so it's the smallest of the three eras following Precambrian time. So we are currently in the Cenozoic Era, the Quaternary Period, and the Holocene Epoch. That's a little bit under debate. There are scientists out there making arguments for whether or not we're currently in a new epoch, and they have a lot of evidence and reasons to believe so. But for the sake of this presentation, we're certainly going to say we're in the Cenozoic Era, the Quaternary Period, and the Holocene Epoch. But geologic time is not ended, and it's still ongoing. Here, this geologic time scale, here's the Phanerozoic Eon, the Cenozoic Era, the Quaternary Period is further divided into the Holocene Epoch. So what we see here's all of Precambrian, some common index fossils. That is, more than 80% of Earth's history. And then you see here the Phanerozoic Eon, the eon of life forms, the abundance of life. The Cambrian Explosion started this Paleozoic era. You see the Paleozoic's the largest, then the Mesozoic's in the middle, the second largest, and we are currently in the Cenozoic era. So generally what we see with geologic timescales is we kind of only focus on, these three eras in general. So what we'll do is we'll zoom into those three, and what we see is, according to the fossil record, we see the biodiversity, increase over time. And we see generally in the Paleozoic era more marine-like creatures, more simple organisms, simple plants, simple kind of animals. During the Mesozoic era, we see a dominance of reptiles, and we see the complexity of life increase over time, where we see more mammals dominate in current Cenozoic era. So in conclusion, the geologic timescale begins with the formation of the Earth, and is created according to all the rock and all the fossil evidence we've ever found worldwide. The geologic time scale is divided into units of time that include eons, which are greater than eras. Eras are larger than periods, and periods are larger than epochs. The Precambrian time was the longest period or age of Earth's history and included the formation of the Earth, where we see very few fossils and simple-celled organisms in the fossil record. The Precambrian time began with an abundance of new organisms arriving in the fossil record called the Cambrian Explosion. This era is the longest of the Phanerozoic Eon and so far, and included many marine organisms such as trilobites. This era ended with the greatest mass extinction of all time, which began the Mesozoic Era, the age of the dinosaurs. A large impact event is thought to have ended this era and the extinction of many life forms, including the dinosaurs, which begins the Cenozoic Era, the current era, where mammals seem to dominate according to the fossil record. And the Cenozoic Era is still ongoing. It's characterized by many ice ages, and we are currently in the Quaternary Period and Holocene Epoch. So that's Earth history in a nutshell. I hope it was helpful. Thanks for listening.